So good morning, welcome to Sakala Vidya educational channel. So welcome to the engineering mathematics classes, and also it will be useful for even B.SC and M.SC classes also. Even it will be useful for different kinds of entrance examinations such as gate examination and other entrance examinations also. Okay, today let us start with the chapter without wasting our time. Okay, differential equations. Differential equations. Differential equations. Okay. So today we shall discuss the important points, that is actually we shall discuss concepts. So after that, formation of the differential equations. Formation of the differential equations. Formation of differential equations. So today let us concentrate on these two. Okay, Sriram, welcome. Sangameshwar, welcome. Okay, this will be useful for your MSET also because, okay, Ramu Tikseti, Sangameshwar and also Vikas, right. So today we shall cover the concepts and formation of the differential equations. Based on formation of the differential equations, definitely one or two questions will appear in the examination. So it may be Osmania University or JNTU or any other universities. So one question will be covered, so under formation of the differential equations. Sometimes so definitions may be given on concepts also. Okay, let us directly move to the concepts first now. Right, the first concept is, what is the definition of the differential equation? So definition. So all of you look at the screen and just note down. If you want, you can pause and you can note down also. So what is the definition? So definition of this differential equation is also a just like equation because, okay, an equation involving derivatives of one or more dependent variables with respect to one or more independent variables is called a differential equation. So this is the definition of the differential equation. right? So see, an equation involving derivatives of one or more dependent variables with respect to one or more independent variables is called differential equation, right? So now let us discuss types of differential equations. So types of differential equations. So next one is types of differential equations. Types of differential equations. Types of differential equations. Is it visible clearly? Yes or no? You need to chart. So types of differential equations. Actually in these classes we deal with the two types of differential equations. One is ordinary differential equation, second one is partial differential equations. Okay, let's have a discussion one by one. So first one is ordinary differential. Okay, Sangameshwar. Ordinary differential equation. So this is generally we called ODE, ordinary differential equation. So ODE, right? Second one we have partial differential equation. Partial differential equation, that is PDE, partial differential equation. Okay, let us discuss one by one. So what is meant by ordinary differential equation and what is meant by partial differential equation? So let us have a discussion. So next, ordinary differential equation, number one. So let's have a discussion on ordinary differential equation. So what do you mean by ordinary differential equation? Okay, let's have a discussion on this one. Ordinary differential equation. See, ordinary differential equation means, so when do you say that the given differential equation is ordinary? So that we need to find out here. So for example, when do we say that the given differential equation is ordinary means the derivatives which are in the equation are ordinary derivatives. That's all, very simple. So a differential equation is said to be ordinary. That means ordinary differential equation. Ordinary if the derivatives in the equation are ordinary derivatives, even everybody can learn this one. Even beginners also you can learn differential equations, very simple manner. So if you attend these classes easily and also note down the clear notes. So once again let me repeat what is meant by the ordinary differential equation. A differential equation is said to be ordinary if the derivatives in the equation are ordinary derivatives. Okay, let us discuss examples here. Ordinary examples, we shall discuss examples. So, examples for ordinary differential equations. Okay, we shall discuss examples for ordinary differential equations. So, first example. So, dy by dx, this is the actually differential coefficient, first order derivative. This also dy by dx whole cube raised to 3 minus dy by dx whole square, plus 7y is equal to cos x. So, this is one of the ordinary differential equation. This is one of the examples for the ordinary differential equation. So, why do we say that as it comes under ordinary differential equation, means it is consisting of the ordinary actually derivatives here. Dy by dx is nothing but ordinary derivative. So, second example. So, what is the second example? d2y. So, we need to read second order as d2. 2 stands for second order. d2y upon dx square plus 5x times dy by dx whole square, negative 6y is equal to 10y. So, it is also one of the examples for the ordinary differential equations. Here d2y by dx square and dy by dx are called ordinary derivatives. You must remember this one. Okay, third example. So, x square plus y square negative x dy plus y times e power y minus or negative 2xy of dx equal to 0. So, this is also ordinary differential equation, this form also. The one more, let us have a discussion, that is fourth one. See, x equals to 1 plus dy by dx whole square and whole to the power of negative 1 upon 2 upon d2y by dx square. So, this is also ordinary differential equation, very simple. So, in the given differential equation, note, write down. If you find, so these ordinary derivatives, so dy by dx, d2y by dx square, d3y by dx cube, and so on, dny by dx to the power of n. Or see, one more thing you must remember, all my dear students. See, the notation for dy by dx we can write like this also. Notation is very, very important. These notations are different from the textbooks. So, it varies from the different authors also. So, dy by dx may be written as y1 or y dash, or you can write f dash x and so on, like that. They are same. The similar manner, for example, d2y by dx square, this is second order derivative, second order ordinary derivative. d2y by dx square we can write y2 or y double dash or f double dash x and so on. So, in the similar manner, for example, d3y by dx cube can be written as y3 and y triple dash and also f triple dash x. So, in general, you remember one thing, in general, So in general notation, in general you remember like this. See, dny upon dx to the power of n, this may be written yn, nth derivative, or y of n, and next f of n of x, and so on. So this is nth order ordinary derivative. Clear? So these are the ordinary derivatives. Ordinary derivatives. You remember one thing. Ordinary derivatives. Ordinary derivatives. Ordinary derivatives. I hope it's very clear to you. Right? Okay. Now let us move to the quickly. So next is partial differential equation. What do you mean by the partial differential equation? Second one is partial differential equation. Partial differential equation. Partial differential equation. Partial differential equation. Right? So a differential equation is said to be partial if the derivatives in the equation have with respect to two or more independent variables. Okay. A differential equation is said to be partial if the derivatives in the equation have reference to or with respect to two or more independent variables. Okay. So now let us write the definition here now. A differential equation is said to be partial if the or directly we can write if the derivatives are partial derivatives. Very simple, you can say partial derivatives. Okay, let's have a discussion on partial derivatives. So that means example first of all. So example, let's have a discussion on example. Right. Examples for the partial differential equation. Examples for partial differential equation. So examples, right. First one, dou 2 y upon dou x square. That means second order partial derivative of y with respect to x. Actually, what is meant by the partial derivative of y means y is considered as the actually here variable and x remaining variables are kept as constants. Dou 2 y by dou x square is equals to 1 upon c square dou 2 y upon dou t square. T stands for, it may be time. Actually this is the physical applied mathematics. Actually it will be useful for engineering sciences also or engineering branches. So this is called actually one dimensional wave motion. One dimensional wave equation. Right. It represents one dimensional wave equation. It is being represented in partial differential equation form, right. So let us move to one more second example. Dou 2u upon dou x square is equal to 1 upon c square dou 2u upon dou t. This represents one dimensional heat conduction equation. So that means differential equations have vast application in engineering branches, all branches. So third we have, so this is dou 2u upon dou x square plus dou 2u upon dou y square is equal to 0. It's very, very important. This is very, very important, right. This is two dimensional Laplace equation. Okay. So example 1, example 2, example 3 are called partial differential equation. So we can study in detail about the in further classes. Actually, moreover, right now let us discuss, let us try to concentrate on actually ordinary differential equations first. So we shall discuss more clear about them. Then after that we are going to discuss what is meant by the order and also degree. So next, what are the, after that, the solutions of the differential equations we are going to study now, right. So next one is order and degree of a differential equation. Right. So let's have a discussion on order and degree of a differential equation, right. So first let us discuss order. What is the order? First let us discuss order of the differential equations. What do you mean by the order of the differential equation? The order of the highest order derivative involved in a differential equation differential equation is called the order of the differential equation. The order of the differential equation. So all of you note down first of all. See what is meant by the order of the differential equation means the order of the highest order derivative involved in the differential equation is called the order of the differential equation. That you need to remember. The order of the highest order derivative involved in the differential equation is called the order of the given differential equation. Okay, now let us discuss examples. These examples are very, very important. So let's have a discussion. Next, examples. Let us discuss examples. Right, first example. X square plus 1 times d2y by dx square. So wait, x square plus 1 times dy by dx plus 2xy is equal to 4x square. So what is the order of given this differential equation? What is the order of x square plus 1 times dy by dx plus 2xy is equal to 4x square? Anybody, can you chart? So what is your answer? So order of x square plus 1 times dy by dx plus 2xy is equal to 4x square. So how could you find out order of the given differential equation? It's very simple. By the definition of the order of the differential equation, the order of the highest differential coefficient, that means you need to focus on the highest differential coefficient which is present in the given differential equation. That's only. So what is the highest actually here differential coefficient? That is dy by dx. So dy by dx is what? First order. So that means obviously the order of the differential equation is, that is nothing but order of the differential equation is 1 itself only. So that means solution, let us write. So how to write the solution means actually here the first order derivative dy by dx is the highest derivative. This is our first observation. Highest derivative in given differential equation. So therefore what is the order of the given differential equation? Therefore order is equal to so the dy by since dy by dx is the first order, the highest order itself is the 1, so that's why order is equal to 1. So problem has been solved. So let us move to the second example now. So what is the order of x d2y by dx square negative of 2x minus 1 times dy by dx plus x minus 1 times y equals to e power x. Now what is the order of this differential equation? So first you need to focus on actually given derivatives. So what are the given derivatives here? d2y by dx square and also dy by dx. Among them, what is the highest derivative? Highest derivative is d2y by dx square. That is second order derivative is there. So as the highest order derivative is 2, obviously its order will be 2 itself only. Am I right? Right. So let us write our answer. So what is our answer actually here? The second order derivative that is d2y upon dx square is the highest derivative, in given differential equation. So therefore, what is its order? So its order is equal to order of the given differential equations is equal to 2. So answer is 2. So let us move to degree. So let us discuss degree. Next, degree. So what is meant by the degree of the differential equation? Degree. So degree will be defined like this. So the degree of a differential equation, the degree of a differential equation is the highest degree of the highest derivative of the highest derivative which occurs in it after the differential equation has been, this is very important, has been made free from radicals and fractions as far as derivatives are concerned. So this is the definition of the degree of the differential equation. So the degree of the differential equation also here, the highest degree of the highest derivative which is present in the given differential equation, but the differential equation must be free from radicals and fractions as far as derivatives are concerned. So there should not be any radical, power should not be radical form. P by Q form. If it is a fraction form also. If it is in the fraction form, we need to make it in free from radicals. Then highest degree of the highest derivative, we need to focus on that one. So that will be the highest degree. Highest degree of the highest derivative. The highest degree itself is the degree of the differential equation, that we need to see. So now let us move the here examples, then we will get an idea. So examples. Examples. So first example, y is equal to x dy by dx plus root over 1 plus dy by dx whole square. Okay, so what is the actually the degree of the given differential equation? So first just look at the question. First of all of you look at the question. What is given actually? What do you observe? So what are your observations? First, if you observe it, as far as the definition of the order of the differential is concerned, first of all, the differential equation should be free from the radicals or fractions as far as the derivatives are concerned here. But whenever derivatives, what are the derivatives here? We have dy by dx, but here we find root. Root is also radical, that is nothing but power is 1 upon 2, fraction form only. So power is 1 upon 2. So it should be made free from the radicals first of all. So that's why when we are going to solve this problem, first of all it should be simplified. So transpose x dy by dx to the actually here left hand side. So being actually transposing x dy by dx to the right here left hand side, what do we get now? Y minus x times dy by dx is equals to root over 1 plus dy by dx whole square. So just think, how do you make it free from the radical? So that means we need to eliminate the square root. How could you eliminate the square root? In general, we know that squaring on both sides. Squaring on both sides. On squaring on both sides. So on squaring on both sides, what do we get now here? This becomes y minus x dy by dx raised to 2 or whole square is equal to 1 plus dy by dx whole square. Now the given differential equation is free from the radicals and fractions as far as their derivatives are concerned. So now actually here what is the highest derivative is present in the equation, that is dy by dx only, dy by dx, dy by dx. Now power dy by dx whole square, what is the degree of this one? Highest degree is 2. So obviously degree is 2. So that's why we can write. So order is 1, but dy by dx only dy by dx is present, but its degree is 2. So now here degree we can write, degree is equal to, so highest degree here power 2. So 2, it should be free from the radicals, you must remember. So this is the first example. So let us move to the second example now. Second example. So let us discuss second example here also, here only, right? Second example. A times d2y by dx square, A is constant only, is equal to 1 plus dy by dx whole square and raised to 3 upon 2, right? 3 upon 2 is in the form of p by q. So now it should be free from p by q form. So that's why here also, so let us do this, solve this problem now. Solution. I am writing directly, squaring on both sides, squaring on both sides. So you may get confusion, why should we square it? Because 3 upon 2 is there, if you multiply 2, 2 will get cancelled, you get 3. Clear? Squaring on both sides, you get a square and d2y upon dx square whole square is equal to 1 plus dy by dx whole square, and it becomes 3 raised to 3. But look for the highest derivative. So highest derivative is this one. This is the highest derivative. d2y by dx square, and it is actually being squared 2. So highest degree of the highest derivative, that is 2. So therefore degree of given differential equation is 2. So this is our answer. I hope you might have followed how to find out the order and also next degree. Okay, now let us move to the definitions of the solutions, different solutions of the differential equations. Okay, so here definitions, right. So first one, actually here we have, right, let us discuss first one. Solution of differential equation. So what do you mean by the solution of differential equation? So that means actually how to solve the differential equation, that we will discuss later in the coming sessions. First of all, we need to discuss what is meant by the solution of a differential equation. So the solution of the differential equation is nothing but it's a relationship between dependent and independent variable not containing their derivatives. There should not be any derivative in the solution or differential coefficients in the solution. So we need to establish a relation between the dependent and independent variables which are not consisting of their derivatives, and also which must satisfy the given differential equation, is called the solution of a differential equation. Okay, it's very simple. Any relation between the dependent and independent variables not containing, it should not contain, so not containing their derivatives which satisfies, that means the relation which satisfies the given differential equation, is called a solution or integral. It may be called integral also. Integral of the differential equation. Of the differential equation. So better my suggestion, all of you make a clear notes. It will be very useful for different competitive entrance examinations also. Okay, it will be very useful for engineering mathematics too. Okay, and also B.SC and M.SC classes also. Right. So let us discuss the types of the solutions of differential equations now. So examples, first we shall move to the example. Let us write one of the examples here. Example. Right, example 1, let us write y is equal to a times cos x plus b times sin x is a solution of d2y upon dx square plus y equals to 0. You can verify. So when do you say that y is equal to a cos x plus b sin x? Here if you observe, see, y is called dependent variable, this y is called dependent variable, and x is called independent variable. This y is equal to a cos x plus b sin x is nothing but the relation between dependent and independent variable. So which is not consisting of the derivatives in that one. So if you substitute y is equal to a cos x plus b sin x in this equation, so it will get satisfied. So that means this equation is being satisfied by y is equal to a cos x plus b sin x. So that we call y is equal to a cos x plus b sin x is the solution of d2y upon dx square plus y is equal to 0. So if you want, you can try yourself. How to check? Once again differentiate, you will get the dy by dx. Once again if you differentiate with respect to x, ordinary differentiation only, d2y by dx square, substitute y for a cos x plus b sin x. So all the terms will be gets cancelled, so that you will get 0. So that's why y is equal to a cos x plus b sin x satisfies the equation. That's why this is said to be solution of the differential equation. I hope it's very clear to you. So if you want, actually you can check also. Actually here what do we call, also you can ask me one question, what do we call about a and capital B? They are called arbitrary constants. Okay, you mention here a comma b are arbitrary constants, arbitrary constants. So that means instead of a and b, you can substitute any constant value. Even if you substitute, you will get the same answer. Clear? So that's why a comma b are said to be here arbitrary constants. Okay, let us discuss types of solutions. Types of solution of differential equation. Right? Differential equation. So types of differential equation, the first one is general solution. Second, okay, second one is particular solution. Third one is singular solution. So how many types of solutions of a differential equation? There are actually 3. One is general solution, other one is particular solution, the next one is actually we have singular solution. Okay, let us discuss one by one. So now the general solution. General solution. General solution. Okay, general solution. What do you mean by the general solution? So general solution means it is consisting of the arbitrary constants. The number of arbitrary constants is equal to the actually the order of the differential equation. So that means a solution consisting of the number of independent arbitrary constants which is equal to the order of the differential equations is called general solution or complete primitive. That also we can call one more term also, that is complete primitive of the equation. Okay, let us write. A solution containing a solution containing the number of independent arbitrary constants which is equal to the order of the differential equation. Order of the differential equation is called the general solution. Or complete primitive. It is also called as complete primitive. Right. General solution or complete primitive of the equation of the given differential equation. This is the general solution. So what is the general solution? General solution or complete primitive. A solution containing the number of independent arbitrary constants which is equal to the order of the differential equation is called general solution or complete primitive. So let us write example now. Example. See, what is the example? Y equals to C1 times e power x plus C2 times e power 2x is the general solution of d2y by dx square 3 times dy by dx plus 2y equals to 0. see d2y by dx square means this is order 2. Here how many, actually here arbitrary independent arbitrary constants are there? 2. C1 and C2 are arbitrary constants. So this is actually one of the examples for a general solution. Next, particular solution. So that means actually in general solution only, here we have C1 and C2. If you give the particular values for C1, C2, suppose if C1 is equal to 1 and C2 is equal to -1, C1 is equal to 2, C2 is equal to 3, then you get the particular solutions. So that means by giving the particular values to the independent arbitrary constant which are present in the solution, then the solution is said to be, that is particular solution. Very simple definition, that is second one, particular solution. Particular solution. So what do you mean by the particular solution? How do you define the particular solution? So it can be defined as like this, right? A solution, this is also solution, a solution, right, obtained from the general solution only, from the general solution, of a differential equation, by giving particular values to the independent arbitrary constants is called a particular solution. A particular solution. To the given differential equation. Differential equation. So let us discuss the previous example itself only. In the previous example we have, see, in the previous example, we have y equals to c1 times e power x plus c2 times e power 2x is the general solution of d2y by dx square minus 3 dy by dx plus 2y equals to 0. Now what shall we do? In the place of c1 put some values, put c1 is equal to 2, c2 is equal to -1. So that implies now we get cy is equal to 2 times e power x and minus c2 minus e power 2x. So this is called particular solution, particular solution. I hope it's very clear, right? So let us discuss the last one, and after that we shall discuss remaining part tomorrow onwards, right? So next one is singular solution. Singular solution. So what do you mean by the singular solution? Let us just think about yourself. So what is meant by the singular solution? So till then actually you watch even particular solution also. Particular solution. Okay, those who want to chart, actually here you need to subscribe, because actually I put subscribers mode itself only. Those who subscribe to our channel, so they are able to chart, live chart with me. So even after completion of this session also you can chart with us, so in the charts box, so that I can interact in the next coming classes. So these engineering mathematics classes will be continued regularly, or at twice in a week, or at least on Sunday onwards these classes will be uploaded. So now let us move to the singular solution. First let us have a singular solution now. See, actually directly it cannot be obtained from any general solution, right, or any choice of their independent arbitrary constants also. That is called singular solution. A solution which cannot be obtained from any general solution. Of a differential equation. By any choice of the independent arbitrary constants. Is called a singular solution. Singular solution. Of the given differential equation. Okay, can you give Example for singular solution, any one of you. I will wait for 5 minutes. In the meantime, you go through the definition of the singular solution. Then we will move to the example. Then after that, tomorrow onwards, we shall discuss very important how to form a differential equation, framing of differential equations. That's very important, because as far as examination point of view concerned, definitely one question will appear in the examination. Till then you go through this is particular solution, this is general solution. First of all, go through the general solution, all of you, once again. Okay, general solution, we have particular solution, okay. Let us discuss the example. Now we will conclude the session. Before going to conclude the session, so we shall discuss the example for singular solution, right? Example. So can you share your example in the meantime? Right. Okay, let us consider y equals to x plus c whole square. This is the general solution of the given differential equation, say equation 1. So now the general solution of differential equation 1 is y1 square minus 4y equals to 0. Or you can write this one as dy by dx whole square minus 4y equals to 0. Suppose say this is equation 2. See, if you substitute y is equal to 0 also here, y is equal to 0, dy by dx also 0, y is equal to 0 satisfies equation 2. So that means we can state that y is equal to 0 is also solution of differential equation 2. So first, if you compare this y is equal to 0 with the general solution, this is the general solution, what do you observe? Here actually it has not been obtained directly from the general solution, simply independently. So now we can write y is equal to 0 also satisfy this differential equation. That means it is not at all depending on even arbitrary constants. That's why this is called singular solution. So that means as y is equal to 0 cannot be obtained by any choice of equation 1. So therefore this y is equal to 0 is called singular solution, is called singular solution. Singular solution. Okay, thank you. We shall meet you in the next session. Bye bye.